Let's take a look at LO 2-5 at the end, where you're given some situations with forces, and you're being asked to identify which of those situations would apply to each one of these 5 questions. So let's start with number 1. In which situation could the sled be moving to the right at constant speed? So if it's moving with constant speed, we have to assume at that point that the forces are balanced. And that would mean no net force. So which of these are balanced and which of these are unbalanced forces? So here we have balanced forces. This, because these two, F normal and F grab, are the same. In this case here, the F applied is an unbalanced force. These two are balanced, and I know that because they're the same length each. These ones are unbalanced because the friction is stronger than the applied force. And this one also is going to be unbalanced. So we can start with that. So constant speed, that would need balanced forces. That leaves 2 options, A and C. And if the object is moving to the right, then that would cause friction to the left. So that could be. But if friction was turned off, or let's say for an object like the hockey puck or the soccer puck that we use in class, if there was no friction, then A could also describe an object moving to the right at constant speed. So we'd have to assume here that A or C would work. And just to make that connection here, this would be kind of like situation A would be like that floating puck that we saw in class. Okay. And so if you want to pause and take a look at number 2, you can. And try it on your own, and then I'll go over the answer to it. Okay, let's do that one. In which situation could the sled be moving to the right and speeding up? So moving to the right, that would cause friction to the left, or no friction if it's a frictionless surface or an air, floating air object. So that means that it could be any one of these 5 based on the friction. But speeding up would mean that it has to have an unbalanced force in the same direction that it's moving. If it's moving to the right, there has to be an unbalanced force to the right. And I see an unbalanced force to the right in situation B. And that's the only one, because C is balanced, D is unbalanced to the left, and E is also unbalanced to the left. So this would have to be just situation B. For a little summary of this here, we can kind of break it down that motion is either going to be constant speed. Let's just say here motion. It's either going to be constant speed or accelerating. And acceleration is either going to be getting faster or getting slower. So with constant speed, talking about the forces, that has to mean that the forces are balanced. Which means the net force equals 0. Or it could also just mean this, or there are no forces at all, which is not really a realistic scenario because there's sort of always gravity unless you're in deep, deep space where it's negligible, so small you can ignore it. But if it's getting faster, this would have to mean that we have unbalanced force in the same direction as the movement. And if we have, I'm going to copy that over here and then paste it over here. If we have an object getting slower, it means we have an unbalanced force in the opposite direction as velocity. And so this is basically the scenario here. This is what we have. So if you want to stick around, and I'll do some diagramming if you like that. So here we have just an object, and the object is moving to the right with some velocity. There are no forces acting on it, or if there are forces, all those forces are balanced. So it could just be like balanced forces. Example, hockey puck. Or I should say air hockey. And if you, to put a diagram with this other case of getting faster, that would mean going to the right, but having some unbalanced force acting on it to the left. So F applied. And although I'm not drawing in the normal force and the gravity force, they are still present there. Okay, and then the last example here, getting slower. Still, let's say we have an object moving to the right, but having that force applied, acting, oops, oh, I said something wrong here. What did I do? I had this other force going the wrong way. So that should have been going this direction, F applied. But in this case, now we have F applied going the opposite direction. We have these diagrams up above on our document. If you want to scroll up and see, it's just the same as these here. Okay. So I hope this helps, and we're going to go over the rest of the answers in class. Thank you for tuning in.